Hi, welcome back. We are going to be talking next to John Skeet. John Skeet is a senior software engineer at Google. He's working on C# for the Google Cloud Platform. And I just saw him last week in person in London. Delightful fellow. John, nice to see you again.
Nice to see you too, John.
So yeah, you're going to be telling us about debugging or Diagnostics 101.
Yes, exactly. So really the background of this talk is seeing a lot of questions on Stack Overflow and realizing that I think that there's something that the community as a whole has been missing for a while, or maybe some of us more experienced developers haven't been passing it on properly, and I've now made this a bit of a mission. So this is in some ways the first or fairly early on in this mission, but I expect this to be something that I'm doing for several years now. So today we're going to be looking at how you fit in as part of the audience, and then also how I fit in. The key techniques that are the basic things you need to remember when you're trying to solve a problem. We'll look at some code. We'll think about what we're going to do if that doesn't work, which usually it does, frankly, and then just wrap up by repeating myself, basically. So it's all very, very straightforward, and that's actually one of the things that I want to emphasize time and time again, that this is not difficult stuff. It's stuff that people don't know about, and there's nothing to be scared of here.
Okay, and John, you're open to questions as we're doing this, right? So people can ask.
Absolutely, yes. Please ask questions. The whole point is I'm not here for the good of myself, speaking into a shed. If I can help you, then chances are someone else will be thinking about something similar at the same time.
Great.
So, as I say, I'm currently in my shed. I can't see anyone. I can't even see John at the moment. So I have very little idea of how many people are listening, how many people are watching later, or where you fit into the sort of continuum of software experience. So if you're reasonably new to programming, then firstly, welcome. It's a fabulous world. I hope you're made very, very welcome by everyone else already in the community. And I really hope that this will help next time you have a problem. If you've been around for a little while, you've written a couple of apps, you're maybe a professional developer already, have been for a year, well, maybe this will reinforce some of what you're already doing, but it may just be that that you see things just occasionally that are new, or it may be just a pat on the back saying, yeah, I've been doing that. That's all fine. And if you're an expert, if you think you know everything you'll see today, then you may well be right. Okay, usually I would say something like, well, you never know, there might be some little bit of trickery about C# that maybe you haven't thought of. Not today. So today is deliberately easy stuff. So if you've seen all of this, then what I want you to think about is how you can pass it on to other people, because I'm sure you will know other developers who are not watching this. Maybe it'll be a case of asking them to watch it on Channel 9. Maybe it'll be a case of pairing with them next time they have a problem. Maybe it'll be a matter of if they ask you for help, instead of saying, yes, you need to fix the typo over here, just take that bit of time to say, well, kindly, I'm trying to teach someone to fish here, but let's see how you could have worked out the solution to the problem yourself, or at least sort of got halfway. So that's where you fit in. What about me? As John said, I am a senior software engineer at Google. I work on the cloud platform, making the experience delightful for C# developers as far as I possibly can. It's a fantastic job, but that's probably not what you know me for. If you know me at all, it will be probably because of Stack Overflow. So I'm very passionate about this whole area because over the last 9 years on Stack Overflow, I've seen lots and lots and lots of problems, thousands of questions, many of which could have been solved or at least much better expressed if the poster had done some appropriate diagnostic work beforehand. Now, I want to be clear, sometimes this is clearly due to laziness. There are definitely questions on Stack Overflow where the person asking the question just hasn't bothered to think at all about, well, what work should I do before asking the question? But I'm fundamentally an optimist, and I don't believe that many people are lazy. So I suspect that some what I think of as basic diagnostic skills are kind of missing. So if you don't have that experience, I want to fix that. As I've said, some talks that I give are sort of meant to dazzle you with cool stuff, and here's async and await, and wow, it looks really complicated to start with, and then you dive in deeply and it's pretty complicated, but you can use it afterwards, and you think, what a clever chap that John Skeet is to understand all of this stuff. Maybe. But this time, there's no rocket science. This is all more about being careful and patient than about being brilliant. I'm not brilliant to start with, but I managed to give quite a good impression of it, apparently, just by being patient and taking some care. So hopefully you can all seem even more brilliant than you do already. So with all of that said, if you get to the end of this talk, if you don't give up in boredom, but you say, well, that was all really simple, that's really boring, then that's good. That is mission accomplished as far as I'm concerned. These are simple techniques. They can be used by everyone. Hopefully I've hammered that point home by now. So I'm now making this a mission to improve the diagnostic skill of the world's engineers, but I can't do very much of that myself. I can do nothing but talk about this at conferences for the next N years. I can write blog posts. I could write a book about this. But it wouldn't help nearly as much as if you all help each other and the community really views this as something that you just don't let it slide. So these days, if someone writes some code that has a SQL injection attack, people are pretty fast to say, hey, you should really learn about this over here. Well, I think we should be the same about diagnostic skills. If someone presents a problem and maybe they've clearly tried, but they just don't know how to proceed, let's give them some help. So what are the key techniques, the 4 things that I want you to really take away today? Firstly, divide and conquer. We're going to look at each of these in more detail. So divide and conquer is about reducing the size of the code base that you're looking at when you're trying to solve a problem. Picking your environment is all about making sure that you're not making your life harder for yourself by working, twisting yourself in knots while you're trying to explore what's wrong. Challenging assumptions, I'll give this away ahead of time. This is mostly about saying your code is probably wrong. The problem is almost certainly in your code, not someone else's. It does happen, but we'll come on to that assumption and many, many others. And the final one was almost I wasn't sure whether to put it in here, but it was keeping a log. It's something I've only started doing reasonably recently, but I found very, very useful. So I'm hoping you will too. Let's take the first of these. So divide and conquer. If I had one technique to remember, it would be this forever. And I can go on and on and on about divide and conquer. Everything else is sort of comes along from this. So picture a scenario. You're working on a medium-sized code base, and it would probably scare many new developers to think a medium-sized code base might be a couple of 100,000 lines of code. This might be a code base that a team of 5 people have worked on for a couple of years. It's not huge. It's not the size of the Windows operating system or the whole of the .NET library, but it's fairly big. And someone comes to you with a problem. They say, when I touch this button on the website, it gives me answer X instead of answer Y. So what do you do? And this is fundamentally where some people will immediately post on Stack Overflow saying exactly what I've just said. People are pressing the button on my website and it's coming up with X instead of Y, without doing the first due diligence of saying, well, how could this happen? What's the code flow? What are the code paths? And how can I just block those off, hard code results wherever possible, and just reduce the size of code that might be wrong? You start off with a mess of code, and you shouldn't feel bad about it being a mess of code. And if diagnostic techniques only worked if you had a well-structured solution, they would be pretty much useless because no one has clean code. I've got a couple of code bases that I'm fairly proud of. Node Time is pretty neat. But I'm not going to say that every bit of it is as nice as I'd like it to be, because there just aren't enough hours in the day. But you start off with a big mess, and then you cut it in half if you possibly can, and you end up with a smaller mess. And then you cut that in half and end up with a smaller mess again, until you end up with a mess that is so small that there isn't any room for the bug to hide. Because basically, bugs love hiding in messy code. The harder it is to understand your code, the easier it is for bugs to creep in. So obviously, I'm all for making code as clean as possible. That'll mean that you have to do this less often, and it'll be easier to do. But sooner or later, you'll get messy code, and you need to cut it down. So you need to get used to a few things that are a bit strange from normal development. Normal, I'm building something new. You're not used to throwing away code. And by throwing away, that could be commenting it out. It could be just deleting whole folders worth of code because you say, I'm going to assume for the moment that the problem isn't in that code. So if I delete it, it can't possibly be causing the problem. Can I still see the problem having deleted it? If so, then yeah, the problem wasn't there. If suddenly the problem goes away, then bring back that code and throw away some other code. You're constantly trying to reproduce the problem with a smaller and smaller amount of code. I'm going to demo all of this in 3 sort of scenarios later on. But you should be used to throwing away code, and if you're going to throw away code, then that's usually code that would have done something. And we think in terms of computer science, functions that take some input and give some output. Well, how about we have some functions that take some input, completely ignore it, and just return some hard-coded output? This is easier with dependency injection, but it's entirely feasible in many other situations as well. So if you've got some code that would have looked at a database, then how about you stub it all out and make the method just return some hard-coded, I will assume my database has these items in. Great, you've got rid of the database. Things are much easier to reproduce now. And that's the constant cycle of reproducing, cutting down. One thing about throwing away code, this is much easier with source control. I'm not going to tell you which source control to use. These days I use Git. I initially started reluctantly using Git, but these days I'm reasonably comfortable with it. And it's really helpful if you can change to a new branch, hack around as much as you like, commit those hacks, and know that you haven't lost anything of any value because it's all still in a different branch. You could go back to halfway through your hack and take a different approach. You can mess around with a lot more comfort, assuming everything's in source control. So if you haven't got source control working first, please invest in source control. Okay, so that's the principle of dividing and conquering. The next one is picking your environment. And I would demonstrate just divide and conquer, but it's all of these come into play with pretty much all tasks. So I'm going to give you the key principles first, and then we'll have a look at some examples. So picking your environment. I really don't want to offend my friends on the Visual Studio team, or my friends who worked before Xamarin was bought by Microsoft, who worked on incredible tools. We have amazing tools now, and I still find it astonishing that even several years ago, I could create a new Xamarin project on my Windows box and plug my iPad into my Mac Mini, and then I could step through in a debugger on my Windows machine, stepping through the C# code, somehow running on an iPad. And that just blows my mind. Likewise, if you've got some client application that's going to talk to a web service somewhere, and you can sort of step into, and suddenly you're stepping into code running on a completely different machine. All this is great, but I don't want to be doing that while I'm doing diagnostic work. Diagnostic work is often about having a quick turnaround from, I wonder whether the problem is this, to, oh no, it turned out it wasn't. Or, yes, that's part of the problem, now can I dig further? It's all about that quick cycle, similar to unit tests, but just very slightly different. So I found recently that while I'm a huge fan of .NET Core. Some of the tooling around .NET Core has not kept up with the main deploy kind of scenarios. So in particular, I've not always been able to reliably step into a .NET Core unit test through Visual Studio. Now, that may well be some issues with my environment, and those are things for me to look at. But at the same time, I think there's a lot of value in coming back to something that I know will work every single time, which is I'll have a console app debugging it through Visual Studio. I can't remember the last time that didn't work. Or even not debugging, just running just running it directly. Let me bring up a console if I can. So my normal way of testing things from Stack Overflow, if I look at test.cs, it's probably a Stack Overflow problem. Oh yeah, okay, so today I was asking, someone had a problem with dates and times, and I wasn't entirely sure what the kind of a date time would be if I just did console.writeline, new date time, year, month, day. So I literally edit it with GED, which is just a lightweight Emacs clone, compile it with CSC, and test it that way. That's how I answer most Stack Overflow questions. That's not sort of the normal debugging of solving your own problems. So if you want to fire up Visual Studio Code, that's fine. If you want to fire up Visual Studio, that's absolutely fine. Maybe I have several sandbox solutions where I can just add a new project and it's not going to cause any problems. Mm-hmm. The main point is, with a console app, there are very, very few other moving parts going on. So if you have ASP.NET Core, look at how many assemblies are being loaded. Does the problem have something to do with one of those? Well, probably not, but maybe. The best way of making sure that it doesn't is to get rid of that from your life, or at least from your life for the next half hour, as it were. So you try to reduce it to ideally a console app, and maybe that won't work because the problem is something to do with ASP.NET Core. Maybe it's how dependency injection works combined with the culture settings on your machine or something like that. That doesn't mean that it's a bad idea to try to reproduce it in a console app, because if you find you can't reproduce it in a console app, chances are it is something to do with ASP.NET Core. You've made progress. You've found some more information. And it's a little bit like the type inference process in C#. It's designed so that every step of the journey, you find some more information. And there's only so much information that you could possibly have without getting to the answer. So I typically early on try to get into a console app. If you find that you can't get into a console app, then okay, it's probably something environmental. So that's the point where your divide and conquer isn't divide and conquer between environments, but in your actual code. And often, instead of reducing your existing code, maybe that's the right time to say, well, I will create a new ASP.NET ASP.NET Core application, start from scratch and try to add code to my environment instead of removing it. Quick word about unit tests. So, and automated tests in general. I love them, and they're a great way of proving that you have found and fixed the bug. But personally, I find them less useful when tracking down the bug. It depends on the problem that you're facing. So one of the things that I want you to take away from today is that you have a brain, use it. Nothing that I'm saying here is sort of normative as the only way to go. If you've got an idea halfway through a diagnostic session and it involves doing something other than what I've said, that's absolutely fine. I'm not looking over your shoulder ready to criticize you. The point isn't criticism at all, it's making progress. So I find that console apps are better than using unit tests when I'm still exploring the problem. But once I've worked out what the problem is, then I will go back to a clean sheet, file a new unit test that does prove. It's much easier to write a failing unit test when you already know what the problem is, but it's a good proof point that you really, really know what the problem is, and then you can prove that you've absolutely fixed it. So don't take any of this as saying that unit tests are a bad idea. They're fantastic. You just need to use them at the right time. And other tools can come into play as well. So if you're investigating a performance issue, then there are great benchmark frameworks available. I like benchmark.net. Your mileage may vary. There are profilers available all over the place. Whether they work with .NET Core or not, some do, some don't. I haven't yet seen ones working with .NET Core on Linux, but I'm sure that will come. So do a bit of investigation. Recently, I wrote a blog post about performance issue, and someone said, "Hey, why weren't you doing things in a profiler?" And it was a situation where the performance issue that I was looking at was so obvious that I didn't need the sort of fine-grained information that a profiler can give. But equally, I could have stepped into a profiler much earlier. Maybe I'd have saved some time. Okay, so that's two of our key principles: divide and conquer and pick your environment. Third one, challenging assumptions. So this is the "it's your code that's wrong" idea. And just to reiterate, if you do have any questions, send them in. Currently feels like I'm kind of speaking to a void. John, are you still there?
I'm here. I'm enjoying this.
Okay, good.
I don't care about the thousands of other people. I'm transfixed here. So.
Okay,
but
well,
yeah, just to echo what you're saying, we're happy to take questions. I mean, this is the person to ask. Bring them in.
Cool. So challenging assumptions. There's one almost given when you're problem solving, which is something isn't working as you expect it to. Because if everything's working as you expected, then why is there a problem? So if you know that something isn't doing what you expect it to, then every time you assume that the problem isn't in a particular area, you're setting yourself up for failure. And to make this concrete, I've seen plenty of Stack Overflow questions that include the phrase, "I know my code is correct," or "I'm 100% sure that this code works." But it clearly doesn't, because you're asking a question. And maybe you're saying, "This code should work, and I haven't yet found where the bug is, but I'm confident it's not my code." But until you know really where it is, I'm not so confident. So question everything. Some assumptions are safer than others, and in order to investigate one aspect, you temporarily have to make an assumption that the problem isn't somewhere else. So usually the problem isn't in the C# compiler. Usually the problem isn't in the operating system. Sometimes it can be in third-party libraries. Third-party libraries vary immensely in quality, and I'm not going to claim where on that spectrum Nodetime lies. But you're generally more likely to find problems in third-party hobby-maintained libraries than in professional code bases where this is someone's 9-to-5 job. All of these things do happen. I've certainly found compiler bugs. I've even read Stack Overflow questions and thought, that can't possibly be wrong. Oh, it really is. Okay, what's going on? And it turns out it was a compiler bug or some weird JIT compiler issue. One of the most interesting questions I read on Stack Overflow was, why does code work quicker when it's in a try-finally block? Literally, there are no exceptions being thrown, but I put it in try-finally and performance jumps by 20%. It's like, no, that can't be right. Prove it. And they proved it. And I was like, what's going on here? So it does happen, but usually, nope, it's in your code. This isn't the only kind of assumption that you should challenge, though, and I've got some very specific things to be skeptical of. So yes, you should be skeptical about your code, but also if you're debugging, if the immediate window doesn't do exactly what you expect it to, just don't trust it. Okay? I'm sure I don't tend to use the immediate window much. I use watches and locals and whatever, but not the immediate window much. I've certainly seen cases where having the same code in the immediate window doesn't do what you would expect it to do when it's actually within your code base. Likewise, when you're looking at a watch window, be very wary of the debugger's string representation. So that's for strings and for floating point numbers. And also, even when you're writing to the console, and one of the great things about writing a console app is, hey, you've got somewhere to write all this diagnostic information. Well, things can be a little odd. Let's skip into our first demo at this point, just to show you exactly what I mean. So if I bring up Visual Studio, I've got a very simple app. This is a console app. I love console apps. And normally I end up running these things without the debugger, but I'm just going to put a breakpoint here and step through in a sec. So firstly, we've got a string that's got a backslash in. We'll talk about how many backslashes it's got in a minute. Next, we've got a string that looks perfectly fine. And finally, we've got a double that is quite clearly close to 5. So what happens when I debug into this? So it starts up. It works because I'm doing it in a safe environment that I'm confident in. And look, let's have a look at awkward 1. So I've just realized that my font for the debugger window isn't as big as it might be, but the debugger is showing me foo /bar just as it is in the string literal here. So you might naively think that the string is foo / bar. What happens when we print it to the console? If I bring up the console, let's bump up the font here a bit because I can do that easily enough. We see it's foo /bar. And that makes perfect sense to me as a C# developer because the string literal here, this backslash is an escape character. The odd bit is that the debugger is showing it as foo / bar. It's really trying to be helpful. It's trying to show you what the escaped value is. So if there's a line break in there, it would show you /r/n. And that can be useful if you know what you're doing. But I will say the number of questions I've seen on Stack Overflow, which are, why can't I get rid of the double slashes in my string? Like, I would bet money that there aren't double slashes in your string. It's just that you're looking in the debugger. Printing to a console is generally better. So having written that out with console.writeLine, I'm now going to call print string, which is a useful diagnostic method. All of this code is on GitHub. I'll show you the URL later on. And when we call print string, it gives us more information than just the original console.writeLine. So it shows you the text, and I've deliberately put apostrophes at the start and end so that if it had leading or trailing spaces, well, leading spaces you'd have seen with a normal console.writeLine, but you couldn't tell trailing spaces. Have a look at the length of it. Yes, it's 7 characters, not 8. And then I've printed out the index, the UTF-16 code unit, and then the printable representation for each character. Now, I'm not doing anything fancy here with line breaks, so if the string does contain a line break, then this diagnostic would say that backslash were actually a line break, then we get one quote on one line and one quote on another, but at least we'd have the U plus 000D or whatever, so we'd be able to tell what was going on. It's important to note that these are UTF-16 code units, which is what a C# string is built up from. So if there's a surrogate pair, that will come up as, that's one Unicode character, but it will come up as 2 UTF-16 code units. We'll see an example of that, well, right now. So we can see find element here. If I just sort of hold down Shift and press arrows, well, you can't tell, but if I say what I'm clicking, I'm tapping now, 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 now. You can see that there were some key presses that didn't end up moving things. And if I do Control Shift right arrow instead, it randomly seems to pick the first part. Well, what's console.writeLine going to do here? It's printed find questionment. Okay, well, that's at least given us some more information than the debugger, which fairly unhelpfully just shows find element. That looks like the original C# code. But when we really find out what's going on is with the print string method. And this is showing, okay, we've got double question marks again. That's fine. But when we look down here, we see 200C followed by 200B. So in this case, this isn't a surrogate pair. These are two regular UTF-16 characters, and we could find out what those are if we just do a web search for that. And I'll need to come out of the slideshow again so I can launch Chrome. So if I just search for U plus 200C, this is something I often do. The first result is usually fileformat.info. Really useful website. And so it's a zero width non-joiner. Yay. And the other one was 200B, which is a zero width space. Yay. I don't know details about what those are, but this was an example that I found on a Stack Overflow question where someone was saying, why isn't this code compiling? And it really looked like it should. And it turns out it had these weird characters in the middle. I didn't actually copy it into C# code to find that out. I'll give you another useful little URL. At the moment, this is not ideally situated. It's just in a random part of my website, but tinyurl.com/Unicode Explorer, Unicode-Explorer, and halfway through an article that I've written about how Unicode works on the C# in-depth website, right at the bottom, there's this Unicode Explorer. Ideally, maybe we can find some way to get it into a Chrome extension or something else. But if I come back into our C# code, if I copy all of find element just straight from, in this case, C# code, but it was copied from the Stack Overflow question as well. And if I just paste it in here, then it will show you the Unicode characters involved and the UTF-16 representation and the UTF-8 representation. So if this had a surrogate pair, it would show us two UTF-16 code units and a sort of 5-byte or 4-byte UTF-8 bit, and it would show the U plus 10 whatever. So that's quite a handy little tool. This is probably the only JavaScript I've written that is still anywhere live, and it makes me nervous. I am not a JavaScript developer. If you want to have a look at that code and suggest how to make it prettier, please do. I think it works. Okay, so if we go back here, one last bit. We've only shown two of the examples so far. Our third one is a double. Now, we can see this time that the debugger is showing a value of 4.99991. I tried to get it to show 5 without the value being 5, and on this particular occasion I failed. But I have seen Visual Studio doing this. I don't know whether this is a difference between running it in x86 versus x64 versus I'm not sure whether this is a .NET Core application. I can't remember, but I've definitely seen it give what seems like wrong answers until you then print to the console, console.writeline awkward 3. We might expect it to print 4.9999991. What's it actually printed? It's printed 5. Because the rules for toString on doubles happen to make that 5. If we call my print double method, this uses something I've had for a long time called double converter, which is ugly code, but it seems to work. Back then, for some reason, I didn't like using braces. I definitely would now. So this is code that you don't need to understand, but the point is it will show you the exact value of a double or, well, a float that's promoted to a double. So people talk about floating point numbers being approximations. Well, the value itself is a precise value that can always be represented in decimal exactly. You can't represent all decimal numbers as binary floating point, but you can represent all binary floating point apart from infinity and not a number as a decimal. That's just because 2 is a factor of 10, but 5 is not a factor of 2.
John, we've got a couple of questions. Do you mind taking those now?
Yeah, sure. Let me just show what that print double
Ah, right.
printed, which was the exact value here.
Oh,
So far longer than we'd ever actually want to see, other than to work out why values are giving. If you've got floating point maths that's giving you what seems to be the wrong answer, if you look at the exact decimal values that are being represented, that really helps. So that was the end of that example, and now would be definitely a good time to take a question.
great. Okay, so we've got two. One from Mark. He's asking, how much do you code for easy future diagnosis? Are you liberal with logging? Do you use more local variables than necessary to check intermediate values? And do you use debugger display attribute on classes?
That's a great question. So I'm not talking very much about logging in this session, because that feels more like a 201 than a 101. Or maybe it's a 102. I'm not from the US school system, so I don't know quite how all of this works. If I'm writing server-side code, then I will add logs in quite a lot. If I'm writing library code where I've got a suitable framework that I can cheaply log to, then that's great. But imagine NodaTime. So this is a class library that anyone can pick up. I haven't got anywhere to log. Maybe this is something that the .NET platform should have, some common logging system, so that I don't need to take a dependency and I could log things in NodaTime. It's almost like something that the .NET Foundation could pursue. However, if I don't break into a sweat these days if I don't have huge amounts of logging. But if I were writing, I used to write server-side code a lot, backends for web APIs type things. And there, yes, logging is incredibly useful. I tend to find that's useful for crash dumps. So I've got an exception, the exception's in the log, but what else can I see for what happened before that? It can be useful for this sort of diagnostic work, but typically what I'm talking about here is situations that you can reproduce and reproduce at will. So if I don't have enough logging in already, I can add logging. Not every problem is reproducible in that form. And in fact, I missed out earlier on before divide and conquer. You've got to be able to reproduce the problem, ideally reliably first. So, find some data that will always give you the wrong result, and that's your starting point. If you are doing forensic debugging of something that's already happened, that's where logging is really useful. The debugger display attribute question, I haven't used it recently enough to remember. My sole recollection of it was that we had to put it into NodaTime somewhere, because if we didn't, it gave the wrong answer in some places. There were some really weird things that might have been Visual Studio bugs. I'm not entirely sure. I think we've got rid of them all now. So it's certainly not a technique that I use frequently. But this is where I'm not the master. I'm just someone who does it quite a bit. So I use my primitive techniques a lot. That's not to say that they're the only techniques available. So I'd suggest write a blog post about where this kind of thing is useful and where maybe it isn't useful. If you find it useful, then who am I to say to stop doing it? Do what you find useful. In terms of local variables, again, I like adding extra local variables. So if I've got, this won't compile obviously, but if I've got something like var x equals foo.bar.gronk.quux, sometimes that's really readable if the method names are more useful. Sometimes it could be far more useful to be to have variables there, not for the sake of debugging, but for the sake of explaining your code. So instead of having a comment saying, first we find the number of unregistered customers, then or we find all the unregistered customers, then we remove ones more than a year old and find the sum of the rest, the count of the rest. Okay. Instead of writing a comment like that, I write var unregistered customers equals foo, var recent unregistered customers equals unregistered customers dot bar var count of unregistered customers, or something like that. I mean, it's rarely quite that verbose, but the number of times that I found that an extra local variable can mean the difference between wanting to put a comment in or not. And I'm not awful for comments. If there are times where comments are useful, typically to explain something that's otherwise not obvious. And the first thing you should always think is there a way that I can make this more obvious? And sometimes there just isn't, because you're thinking about some boundary condition that is never going to be easily explained in the code as much as in text.
Okay.
Okay, so that was the first question. What was the second
so
question?
we've got 3 more questions and 20 more minutes. I want to make sure you get time to cover what you've got left. So I don't know if you want to...
Do you know, early on in this, I was thinking, I'm going to run out of material before I run out of time. That never happens, and sure enough, it's never going to happen. Well, you ask the question, and let's see if I can deal with it quickly.
Okay, well, Tuberk's asking, what are your approaches on diagnosing unexpected CPU usage or problems in .NET applications, especially when you can't easily identify the area in the code base where the problem's arising?
Okay, I will come back to that in example 3. It's not quite there, but it's sort of halfway. Okay, so let's get back to the PowerPoint at this point and see, right, the fourth technique. So after we've worked out things that we're skeptical of, and the last bullet point here of that article you read a few months ago, that could also be your team lead saying that it's a bad idea to do something, but without really wanting to explain why. Generally, if I can't put my hands on it, then I'm not going to believe it's true. Okay, fourth area is keeping a log. So this is something I wish I'd started doing earlier. When you're doing diagnostic work, particularly for something big, where big is usually in terms of the time it takes. I remember tracking down a memory leak in gRPC. It happened to be a few months ago, and it took me a day and a half to track down exactly what was wrong and propose a fix. And that's quite a long time, and my brain isn't very good at keeping track of what's going on. So I started writing a log really early on. These days, actually, I start writing a log in terms of a blog post, because this is a mission of mine, so I'm blogging the experiences and hoping that people can learn from it. Feel free to do that as well, but you don't have to. A Word document is fine. It doesn't need to be pretty. You're primarily communicating with yourself, and it's unlikely to be a long-lasting doc as well. What you are aiming for is accuracy, and copy-paste is your friend at this point. So if you've run some tests and they've taken a particular amount of time, then copy and paste that, the exact command you ran and what happened into the log. Maybe you've got a very big log because it's run thousands of tests and you've got thousands of results. Attach that as a file to the document, or keep it with the document somewhere. And maybe that's log1.txt, and you put the results of this are in log1.txt. And this kind of log isn't about adding logging statements to your code, although if you have got logging statements, then that output ends up as part of this log. If you're trying things in lots of different Git branches, make a note of which branch contains which code. Likewise, if you suddenly think of several different assumptions, make a note, maybe even make headings that you're going to come back to later on. Keep track of ideas. And if something turns out not to be the problem, you don't delete that heading from the doc. You still record that you tried it, because the whole point is you're adding information about where problems aren't. So you don't want to do something 3 times and think, oh yeah, I've already tried that and it didn't, the problem wasn't there. And finally, logs like this can be great for self-improvement. So when you fix the bug, patted yourself on the back, you've committed merge the fix, look back at the log and say to yourself, well, where might I have found the problem earlier on? Where might I have brought a profiler in earlier on? Who knows? You can get better at this. Okay, and very finally, before I demonstrate some of these techniques, I want to say a little word about people. So pretty much every bug is caused by a person, and that may be you, it may be somebody else. If you don't resolve the problem, or if you find that it's somebody else's fault, you're likely to be communicating about that problem with people. And I want to ask you to bear three things in mind here. Firstly, we're all human. If you find a bug in no time, I am really, really sorry, and I will try my best to fix it. But if you file the bug report with a positive attitude in collaboration, sort of, let me help you find this, let me work with you, then I'm much more likely to, frankly, drop everything else and help you than if you come saying, no time's rubbish, it's got the date wrong for this, but without any effort of the diagnostics, without any understanding that I'm a busy person and you're taking code that I've given for free. Bear people's emotions in mind. Tech is not an emotion-free zone. Second point to bear in mind is that the other person may not know your context, and a lot of the divide and conquer work that we've talked about is about reducing the amount of context that's relevant, but please do provide that context. A little word about, this is why I'm trying to do this. Doesn't need to be reams and reams and reams, but just a little bit. And finally, communication is often imperfect because, again, we're human. So really put effort into being as clear as possible. Okay, all that said, let's have a look at some examples. So first, let's look at a sample website. So I won't actually run this, but we have, I will actually. So here we have an ASP.NET Core application, and it's got a reporting element to it. So when I eventually run and it comes up, this is just a regular ASP.NET Core 2.0 application, I think. I am running it in the debugger. If I hit reports, then it will come to an empty page from a download the report link. So imagine this were part of a much bigger application. We hit download the report, and in fact, in this case, we get an argument exception. Imagine if instead of the argument exception, we had got the wrong report data. That's the problem that I'm trying to fix. So I know that I'm coming to the download XML bit of my controller, and that's doing some date time parsing and then getting a report and then formatting it as some XML and then saving it to a stream and then saving the file, saving it as a file for the client. So it's returning an ASP.NET Core file response. Okay, so there's a lot going on here. How can we cut it down? So the first thing I would do is say, well, we've got this repository, and I know that the repository we're using is SQL based. I'm going to come out of the debugger now. So in my models, just for convenience, okay, I've got an interface, but I happen to know that the implementation I'm using is this SQL based one. And I hope your data code is a bit better than this. This isn't actually going to go anywhere because when I look at my configuration, the connection string is real string. But the point is, I've got this SQL code.
Hey, John, can you hear me?
Yeah,
Hi,
I can.
This is Scott Hanselman, your wonderful friend, and I just think you're just such a lovely person. I rushed the stage to say hi. Could I impose upon you to just control scroll just a smidge and make those fonts bigger? So I can appreciate you in even larger font.
He's got old eyes. What can we do?
It's an old eyes. Thank you so much.
That better? Okay, cool.
Thank you, sir.
So we have this reports controller that is SQL based. Is the problem here? So the first thing I would do is get rid of the ASP.NET Core part. I've got rid of the XML part. All we've got here is the reporting side fetching it from a database. And I've literally just cut and pasted the get report code In this case, I've done it for the sake of demonstration. I've done it in a separate project. Maybe you can do it in a separate project. Maybe it's easier for you to say, right, well, I'll commit all the code that I've got, so I definitely won't lose anything, and then I'll just start deleting bits. That works too. You can often create a whole new console application that depends on your ASP.NET application and just start using bits. You could even just change your program.cs for the ASP.NET Core. This runs a web server, but it doesn't have to. You could change your main method to stop doing that and just say, well, I'm going to new up a reports controller, passing in the right connection string, and then I'll run it. No one's going to necessarily see this code. You're not going to check in. If I do exactly that, var SQL bits equals new reports controller, my connection string. And you know what? I've got a typo and I just don't care because no one's going to see this code apart from everyone watching this video. But in real life, in fact, it needs to be a config. Sorry, it's not even the controller, it's the report repository. That's fine. I've got a bunch of unused using directives. Again, I don't care. And this needs to be a configuration of a report configuration or something like that. But I can easily hack. In fact, do you know what? I can't even be bothered to create the report configuration. I will just get rid of my config and have connection string. And I'll remember that. In fact, blow it. Let's just make it a parameterless constructor, and I will hard code my connection string here. Okay. So now in program.cs, this sort of half zombie ASP.NET Core application, I can now just call SQL bits.getReport and then pass in new date time. I can do everything there. Hey, I've got a console app. I can just delete the views now. No one's going to care. I can delete all the controllers. No one's going to care because I'm never going to merge this. I can delete stuff to my heart's content.
John, just wanted to give you the heads up. We got 8.5 minutes left.
Right.
So.
Cool. Okay. So I will whiz through. So this was an example of how I could have attacked the SQL code. Oh no, the problem isn't in the SQL code. Let's just go into let's go into Git projects demo code git reset -hard, and you know all that code that I didn't want to lose. Hey, it's back there. So now I could do exactly the same, but with the XML parts, and say, oh well, okay, instead of using repository.getReport, I could come up with something else to hard code things. Or you can do it in a different console app. So here's a console app for the XML. And the final thing, because it's always the final thing you check that's wrong, because why would you check anything once you've found the problem, is it's actually around datetime.parse. And I can do diagnostic work printing out datetime, or I can print it out with a culture invariant representation so I know exactly what's going on. Or I could print out datetime.year, datetime.month. This doesn't need to be pretty, it just needs to work. So that's the first example. You can dig through it in the GitHub repo. Second example, I've talked about a lot about web apps. What about UIs? Well, what happens if I've got a UI that doesn't do what I want it to? This is meant to get all the cloud storage buckets that I have access to. Imagine this were a huge UI. And, well, okay, I'm seeing one button, but I meant to create one button for each of the elements, the buckets that I have access to. So that's clearly not working. Well, what's wrong? I can step through in the debugger. I'm not going to show that now because we don't have time, but that would definitely be one of the options. I can check, does this have anything to do with Google Cloud Storage? Is it this wonderful google.cloud.storage.v1 library that I'm using? Let's prove that the problem isn't there. We can prove that in a console app really easily. If I set that as the startup project, I can run through and just print loads of things. Great. That all works. Okay, well, what about the form? It's got sort of buttons on and things. Surely I can't produce... if I've got all this designer code, how am I going to reproduce this and show someone else? Well, the answer is this is a fully written UI. I've just not got any designer code. I wrote this by hand because it's only 27 lines of code in total, and it demonstrates the same problem. With hard-coded data, I'm only seeing foo instead of foo and bar and bat. In this case, the problem was I'm not setting locations, so they're all on top of each other. But the point is, this is somewhere that I can't demonstrate the problem with just console output because it's a UI problem, but that doesn't mean I can't reproduce it in a minimal way. Having said earlier on that we would look at the example of performance, we really don't have time. Fortunately, that's one I have written up earlier. If you look in, for one thing, codeblog.johnskeet.uk, and if you click on Diagnostics as the category, you'll find all these blog posts that I'm writing about exactly this. And you know, there's a lot to read. But if you search for tracking down a performance hit, you'll find basically the exact steps that I've got in the downloadable code, that it turned out to be a problem with ends with, string.ends with. You know, I told you that sometimes it's in the core libraries, but I only found it through NodeTime, through NUnit, and I really didn't know whether the problem was in NodeTime or NUnit or something else, or in .NET Core for Linux. Turns out that it was about localization, so other people might not have seen it even. But it was a good example of stripping down. The first thing that I removed in this case was NodeTime. I wasn't I was expecting to just remove some of the NodeTime code from the problem. Turns out it wasn't to do with NodeTime at all. Dig into NUnit. Is the problem in NUnit? Well, hey, here's a suggestion for how to improve NUnit. Fine, but the underlying problem was in .NET. I was able to reproduce that with the final example, which I posted, is a straight console app. So I can run that, I can post results onto GitHub in an issue, and suddenly we know, everyone can reproduce that with enough effort, or rather with very little effort. So having raced through those demos, if you are still stuck, then that's when you hit Stack Overflow or GitHub. And by this point, you probably know whether you've run into a bug somewhere else, or whether it's some weird problem that maybe is a few things coming together. But now, if you've got a console app that's sort of 30 lines of code and shows the problem, that's a perfect Stack Overflow question. So you say, this is what I'm trying to do. Here's some code to demonstrate it. This is what I expected the results to be. This is what the actual results were, or here's the exception stack trace. At that point, you're being a really good citizen. You're going to help other people who are running into the same problem. Maybe it's a problem with your understanding of something. Maybe it's a bug in a library. And by providing that kind of reproduction, that bug will get fixed much quicker. Okay, I'm kind of out of time. Things to remember. Divide and conquer, absolute heart of all diagnostic work. Challenge all the assumptions that you've got, particularly that it's your code. Make sure you're working in a simple environment. I like console apps. If you're more comfortable in ASP.NET Core, then that's fine. But I would say that console apps are great for then sharing the code later on. Really important. Despite me having to speak quickly in the end, there was a lot to go over here, but none of it was difficult. Hopefully no one has thought, wow, I didn't understand how that bit of code could work, because it was really simple. Okay, I've included a couple of bits of code to do extra diagnostic stuff. You can just copy and paste that double conversion code, the string dumping code, all of that's fine. Use that as liberally as you want. Finally, spread the word. I can't do all of this myself. Everyone should know about this. It should be sort of basic, fundamental human developer right, is knowing how to get cracking when you solve a problem. And finally, the code is on github.com/jskeet/demo code, and I'm sure we'll link to it from Channel 9. I'm done.
Awesome, John. So we had a few questions, don't have time for them. Is it okay if people ask you those maybe on Twitter?
Yes, absolutely. Twitter or by email. My email address is on Stack Overflow, or maybe the comments in Channel 9 would be a
Sure.
really good place to sort of be with the video.
Great. Okay, well, thank you a bunch. Next we're going to have Michaela Hutchinson. She's going to be talking about Visual Studio for Mac, server, games, and more. So stay tuned.